Hello, MBA 510 students. This is Professor Hazar again, and this is the second video on cost, volume, profit. In the first video, we had been working with a spreadsheet. We had been building a spreadsheet here. Okay, and at first I just gave you some basic definitions of cost, and I gave you a situation where we used cost, volume, profit to compute the break-even point for this company, whatever the company's name is, who cares? But this was the data, basically. The sales were 2,000 units. $50 per unit was the sales price. 100,000 total was the total sales. Variable cost per unit was 30. 60,000 was the total variable costs. Now, your contribution margin, and remember that I said this was the most important, I would say the most important concept here, is the contribution margin. And what this is telling you, once again, I'm going to try to say this again, this is the amount that the sale of one unit will contribute toward meeting fixed costs before the break-even point, and once you meet your fixed costs, you're at the break-even point, and contributing to profit after your break-even point. So up to your break-even point, each unit you sell is contributing $20 to meet your fixed costs. Past the break-even point, $20 of profit. Okay, and we had computed, I'd gone over these formulas, but the break-even point in units is computed by taking your total fixed costs, dividing by your sales, your contribution margin per unit, okay, which is sales price less your variable costs, okay, which is $20, and then we can compute your break-even point in dollars, which is 25,000 divided by your contribution margin ratio of 40%, and you could get the same thing simply by taking 1250 break-even points and multiplying by $50. And the second concept we dealt with is rather than just breaking even, we want to target net income of $30,000. So then you've got to cover both your $25,000 in fixed costs, which is up, which means that you make an income, which means, well, you make an income of 15 at that point, but you've got to cover $25,000 in fixed costs. $30,000 in target net income. Now, the target net income was just assumption. The 30,000, you can have 35,000. You can target any income you want. Okay, but I assumed 30, and in order to not only break even but cover your fixed costs, you also covered your target net income, which would be 2,750 units. And if you want to cover both those, 55,000, and divide by your contribution margin ratio, that would have given you the sales you need to make to cover your $25,000 fixed cost and to achieve a $30,000 target net income. You need $137,500 in sales, and I wanted to emphasize that this equals the 2,750, which is the number of units you need to make $30,000 target net income, times $50, and that gives you the same number. So you can compute that either way. Okay, now in this example, it's kind of interesting. I'm going to make a graph of all that. And so what I've got here, it's the same worksheet, basically. Top, I've got the same data, and then I've got the same numbers that I just gave you. And what I'm going to do now is I'm going to show you how to make what is called a cost, volume, profit graph, a break-even graph. And I've got 4 columns for that. First one, these really are units, which are going to go up in increments of 100. And then for each increment of units, I'm going to give you total sales, which is very easy. Then I'm going to give you total costs, and total costs are going to be equal to your total fixed costs times your total variable costs. Now, your total variable costs are going to be, I might as well stretch this out. Total variable costs are going to be your variable cost per unit times X, which is the time, I'll do times X, which is the number of units sold, and let's take the 8 out of there. So variable cost per unit times X gives you your total variable cost. Now your total cost is equal to total fixed cost plus your total variable cost. Now your total sales is going to be your sales price per unit times X, which is the number of units. Okay, and I don't know why I keep doing that. I think I'm hitting the. Okay, so let's start with 0 units. 0 units is equal to it's always your base because you may have 0 in sales. Okay, now we're going to go up. Let's do this. Do this equation. What we're going to do is we're going to start with the previous cell, and we're going to add to that this 100 in units. So that means that you will that you'll sell. That's the scenario is 100 units sold. I'm going to go ahead, that is G11, and freeze G11 so that we can then copy that formula down, and it should be providing us, we'll go up to 3,000 units because 2750 was 2,100. Let's go up to 3,000 because 27, we want to go up to the point at least where we hit the target net income level. And I'm going to go a little bit past that. Just a couple past that, 3,000. Yeah, that's fine. That's fine. Okay, so that's different assumptions about the number of units sold. We're saying we sell 0, 100, 200 units there, et cetera, et cetera. Now this really, let's say that I want to emphasize that this number of units is the variable X. So your total sales are going to be your sales price times X. Now your sales price is $50, so I'll go ahead and I'll be freezing that, and I'll just be taking the sales price times X, which is the different levels of sales. So the first one is going to be 0 times 50 gives you $0 in sales. That's obvious. You've been selling units at that time. I'll go ahead and freeze the sales price. Okay, and then I'll just go ahead and take this down. So this is total revenue, and this is total revenue. Okay, but notice it starts at 0. So your intercept here is going to be 0, and that makes sense because if you sell 0 units, you have $0 in sales. Now your total costs. Now we know that your total fixed costs are going to be your total fixed cost plus your total variable cost. Now we know that your total fixed costs are 25,000. So I'm just going to go ahead and take a negative 25,000 there, which gives you positive 25,000, and I'll freeze it. Let's go ahead and freeze that. So we'll freeze the and the 8 there. Okay, so we'll go ahead and take the total fixed cost down to here. So your total fixed costs are going to be a straight line, a straight horizontal line. They don't change. And finally, your total variable costs are going to be your variable cost per unit, which are $30, and that's times the number of units sold times X. Okay, so your total variable costs are going to be your variable cost per unit. And I'll put a negative in front of there because we don't want a negative. Okay, we're actually going to add it here, so I'll put a negative. It's a negative, so I'm going to make sure that's positive. And we're going to multiply that times the number of units sold. Try it again. Okay, so it's going to be that number, doesn't matter the order, and it's going to be times your variable cost per unit. Okay, and we want to make sure to do two things here. Make sure that the variable cost per unit is negative, we'll get negative numbers, and then we'll freeze the cell. Go ahead and freeze the cell and see what we get. Let's just make sure to try it down here. We want positive numbers, obviously. That looks pretty good. Okay, so let's go ahead and copy that down. Okay, and so, your total costs are going to be your total fixed costs, which is like a base cost. You can't avoid those. You have to pay your rent, you have depreciation, you have to pay your insurance policies. Those are all fixed, so it doesn't matter if you produce 0 units or 700 units. Your fixed costs are going to stay the same, whereas your variable costs are going to go up at a rate of $20 per unit, and everything looks good here so far. Okay, so let's go ahead at $30 per unit. Your variable costs go up $30 per unit. So your total fixed costs are going to be total costs are just going to be your total fixed costs plus your total variable costs. So this makes sense. If you produce 0 units and sell 0 units, your total costs are equal to your total fixed costs. Then they start going up by increments of 100 times the $30 variable cost. So here are your total costs right here. Okay, so and that's kind of looking good here. So let's just go down here. I want to make sure we got them all here. And I'm just going to graph this out up to 3,000 units. I'll make sure to include the 2750 target net income amount. Okay, so how do you graph this? You're going to graph this is actually going to be fairly easy. And I'm going to go ahead and simplify this title. I'm just going to put here units X. That may not even come out on the graph. Okay, but I want to make sure that we keep this simple for the graphing tool. Okay, so let's go ahead and do this. We're going to bold. We're going to go ahead and bold everything starting with the titles and all the way down here. And notice what we've got in here. We've got our total sales. The line, we're going to have 3 lines: total sales, total cost, total fixed cost. Okay. Now let's go down here. And I'm going to go to insert, and then let's see what charts it recommends. I like this chart right here because it's a line graph, and it looks like it's graphing all 3 lines. If you look at this one, for some reason it's only graphing 2 of the lines. It's just the style of the chart. Okay, so I'm going to go ahead and graph that line, that chart right there. Okay, and that looks good. This is looking very good. And notice, I don't see if you can see the cursor sometimes, because sometimes there's a cursor cut. But you'll see a gray, straight, horizontal line at about $25,000. Keep in mind that the left-hand axis is going up in dollars, but by increments of 20. So that gray line does look like 25. That's your fixed cost line. And it's specified, total fixed cost. And your total cost line starts at the fixed cost point and goes up to the orange line. Your total cost line is the orange line. And notice that it starts, your minimum fixed cost, your minimum total cost is $25,000. And then it just starts going up at a rate of $30 per each unit sold. Okay, so if you produce 200 units, then that would go up an extra 6,000 maybe. And there it is. If you produce an extra, you start at 0, 25,000. And then if you produce another 200 units, they go up at a rate of $30 variable cost per unit. So it's 25,000 plus 6, that gives you $31,000. So the graph is right on. And then this blue line is your total revenue. And that makes sense because, like I want to try to emphasize before, is that line right there is your total revenue line. Okay, so let's go ahead and just let's see if we can do this, see how fast this comes out. And of course, it's going to try to give me too many bells and whistles. CVP, let's just call the graph CVP. Okay, and let's take this out of here. And let's see our graph again. And I'm just going to put a couple labels on there. Okay, and the first label I'm going to put on there, see if I can do this right. I'm going to insert a text box here. Let's see if I can insert a text box. Okay, and I'm going to insert 3 text boxes. 1. Okay, and I'm just going to put BEP there for break-even point. So I'll go over here. I'll go ahead and I'm going to copy one over to here. Copy here. I'm going to copy one down here. Okay, and then I'm going to put some arrows in here. No, well, I'm going to put the word loss here. I'm going to put the word profit here. Okay. And I'm going to put some arrows here. I'm going to put some shapes again. And just an arrow. And then your break-even point, I'm just going to put an arrow down to there. Where those 2 lines cross is your break-even point. That, your 2 lines cross, that is your break-even point right there. Okay, and that's where total revenue line is equal to your total cost line. That makes sense. And notice that your break-even point, it crosses at about 1,270 units. So you're looking at units along the horizontal axis and dollars along the vertical axis. And the break-even point is where the total revenue line crosses the total cost line. Makes total sense. Now, I'm going to put the profit line. I'm going to insert another little arrow here. We'll do this. Shapes. Put an arrow here. And this region right here, I'm not pointing it, I'm setting that point at a region. That region is profit. And that makes sense because it's to the right of your break-even point, and that's where your total sales are actually, your total sales line is greater than your total cost line. And then finally, as you may have guessed, there's a region to the left of the break-even point. I'm going to go ahead and put in another shape here, another arrow. And as you can guess, this region in here, I'm pointing at a region there. That region there, the whole region to the left of the break-even point is loss. That makes sense because at that point, your total cost line, which is orange, is greater than your total sales, total revenue line. So you start with a loss, and then the more units you sell, the smaller your loss gets. Then you hit the break-even point where total sales are equal to total cost. You go to the right of the break-even point right here, and notice that your profit gets bigger. So as you go from the break-even point out right, you're making a lot more money. So you're making a lot more money at 3,000 units, which is the last part, than you would be at 2,000 units. That expanding region is profit, whereas that shrinking region to the left of the break-even point is loss. Okay, now I want to do two things here before finishing this video. I want to ask myself, what are the things that affect the break-even point? And I'm going to be pessimistic here and do things that make my break-even point go up. And keep in mind that companies always want to keep their break-even point low, because the reason for that is you want to start making money as early as possible. You would rather start making money after producing and selling 800 units than 1,275 units. Now let's see. We have calculated here that our break-even point is, 1,250 units. Okay, and in dollars, the break-even point is 62,500. And if you go down to the graph, that looks about right. You got 1,250 and it's over 60, about 6,250. Okay, so that break-even point looks exactly right. So, and keep in mind on the 1,250, that's the number you want to keep your mind on here. Let's go up here and let's just say that rather than being, and we're going to see how this changes. Remember, our break-even point at 25,000 fixed cost here that you have to cover is 1,250 and 62,500. Let's say our total fixed cost went up from 25,000. So let's say let's say it went up to, let's make them 30,000. And I want you to keep an eye. I'm going to do this. You should keep an eye on that number there, that break-even point number. Okay, so let's go ahead and raise this to minus 30,000. Now you see that the break-even point went up, which is not a good thing. You'd rather start making your first dollar profit after 1,250 units than at 1,500 units, and you also have to sell more in terms of dollars in order to break even. But let's see what happens to the graph down here. Now it's hard to tell, but notice that the break-even point changed. This is why I put arrows in it. It was here. The break-even point has now moved. Let's see if I can move this thing. The break-even point has now moved right there. So the break-even point, by raising your fixed cost, and you'll see now that I can even try to shrink this a little bit. This is still loss. This is still profit, but you don't start making a profit until, let's see if I can buy a point. You don't start making a profit until, so your break-even point, as you saw up top, was 1,500 units and $75,000. That's your new break-even point, whereas the old break-even point was, I believe, 1,250 units and $60-something thousand. Well, we can change that again. But the point is that when fixed costs go up, your break-even point goes up. And what's happened, you didn't see it maybe, is that the whole total cost line, the fixed cost line and the total cost line both shifted up. So there was no, the slope of the total cost line stayed the same, but your total fixed cost went up. So basically they both moved up, which moved the break-even point up. Okay, I'll let you play with that on your own because I will be sending you this. I'll wait for this. This is always getting stuck here. I'll be sending you this video on my own. Even if I finish here, it'd be good. Okay, and let's go back to our original. Right, so here it is. So here's the first rule. When your total fixed cost goes down, your break-even point goes down. Your total fixed cost goes up. break-even point goes up. Now think of that in terms of managerial decision making. So if you had people in your accounting department, I hate to say that, or let's say your legal department or accounting department, which you think you could lay off, that would lower your total fixed costs, which means that you would lower your break-even point and you would become profitable at an earlier or lower level of production and sales. Okay, now let's go ahead, and the other variable that changes your break-even point is variable cost per unit. Now, this variable cost per unit is the slope of the total cost line. So if you look at that orange line right there, your total cost for every unit you produce and sell, your total cost, your variable costs are going up by $30 per unit, and so are your total costs. Okay, let's see if we increase that. Let's see what happens to our break-even point. Now, I've gone back to, let's go back to the original negative $25,000 here. That gives us our original break-even point. Let's just go back to I don't know why it's doing that, but let's change that to no. Oh, I know what I did. Make this negative. That's 15,000, and then just do this. I'll probably have to change this. Oh, why change that to dollars? That should be units there. Hope I didn't start with units for itself. Okay, we'll go to number and that. Okay, so we got 1,250 units, $62,500. That was the original situation. Okay, so let's see what happens, and we'll take a look at the numbers initially. Let's see what happens if our variable cost per unit increased to 35. Let's see what happens to that break-even point right there. And once again, if you have a high break-even point, not good, because you don't start making money as fast as you would as if you had a lower break-even point. Let's change that to $35. Okay, so that should be. Okay, so our contribution margin is now $15. So your contribution margin went down. So our fixed costs stayed the same. That's fine. But when we increased our variable cost per unit, that decreased our contribution margin per unit, which is sales price minus variable cost, is now $15 per unit. So even though our fixed cost stayed the same, the contribution of each unit toward meeting fixed costs and then making a profit is less. So you got to sell more units in order to cover the same amount of fixed costs. And to be specific, you now have to sell 1,667 units to make to break even, and that is in sales. That's $83,833. Let's see what happened here. Notice that your total fixed costs on the graph are now the same, but notice that your break even point has shifted even more. It's now 1,600. So you see the break even point is right there. So it shifted up, and the reason why is because total sales line stayed the same. That blue line stayed the same. The total fixed cost line is still $25,000. That stayed the same. But the slope of the total cost line changed because your variable cost changed. And so that means that your break-even point shifted out to the right again. And so maybe, and I'll finish the video here, but let's just go up, drag this thing up here, and see if we can do this on a more real live perspective here. Okay, this will be a nice dramatic way to finish this video here. Okay, so let's go ahead and just take this up here. Let's do the two things we just did. Let's go ahead and first of all, let's go back to our original amount. Our original variable cost per unit was $30 per unit, so let's go minus 30. Let's put a 0 there. You'll see what happens on the graph. Okay, that line shifts down. Okay, and so my little lines are dragged out, but you get the point there. So let's see what happens when we raise total fixed costs. Look at the graph. See what happens when you raise total fixed costs. You'll see that both the fixed cost line and the total cost line go up. Okay, so we're going to change that to 30,000. You'll see. Now watch the graph. Well, it didn't go up, but the number shifted down. The break-even point did go up. It's 1,500 now, and that's more or less where the two lines cross. That's exactly where the two lines cross right there, point 1,500. And this one, I hope, this next one, I hope, is more. What's happening is the numbers are shifting, graph rescaling. So you didn't see anything change, but you saw the numbers change. So if you look at the numbers, let's go back to the original 25,000. You're going to see the numbers on the left-hand side change. You'll see the numbers change, or the units change, actually. Okay, so the units change, so the break-even point goes back to the original 1250. That's the point right around there. It's only going up in 100, so break-even point between those two numbers right there. Anyway, and let's see what happens. There's ways to freeze, actually, those axes. And let's just try the change we made to, let's change this to $35 and see if you get a different, you should see that slope change, and it did a little bit there. So that's what happened, the slope change of the line, and they rescaled the two. But anyway, so the two lessons here are, if fixed costs go up, your break-even point goes up. That's not good. Your break-even point going up is never good, because you will be making a profit. You won't make a profit until selling a larger number of units. You want the break-even point to be as low as possible. So when your fixed costs go up, your break-even point goes up. When the fixed cost goes down, your break-even point goes down. And the opposite is true for, let's just say variable costs. When your variable costs go per unit go up, your break-even point will go up, because I'm just changing back to the original graph here. Because when your variable costs, so when your fixed costs go up, you can see from the fraction, your break-even point goes up. Now, when your variable costs go up, that VC goes up. That means that you're going to have, your unit's going to be contributing a smaller amount, so you'll have to sell more units to cover the same amount of fixed costs and then cover profit. And I think that more or less will change this. When I do the video, and I'm going to put up the videos, this is Saturday night, Sunday morning, excuse me. I'll also send you this worksheet, or I may have you make the worksheet. I'm still thinking about that. But once you see the worksheet or make it, then you'll see how this thing works. But the major thing is, this equation tells you all. That's your break-even point in units. You can see, just looking at this arithmetically, if your fixed costs go up, so does your break-even point in units. And then if your contribution margin goes down, and your contribution margin goes down, usually it's a variable cost thing. If your variable costs go up, that means your contribution margin per unit goes down. And my illustration was, I made this into a negative 35. You'll see that the contribution margin per unit went from 20 to 15. That means you've got to sell more units to cover the same amount of fixed costs, and that's not a good thing. I'm going to go ahead and change this back to the original, and I think this should help you a little bit to start to understand the chapter. And I will be in touch. Thank you very much. I'll be putting up this video very